Okay, so this is the question 1 in homework 2 for probability, random variables, and stochastic processes. So now the question that we know is that this function that we have, this represents the probability of the customer flow at a grocery store, and it follows the Poisson process. So what this says is the probability of the number of customers in a time period 0 to t is equal to k. The probability of this entire event is equal to exponential to the power minus lambda t into lambda t to the power k by k factorial. That's exactly the equation of this thing, Poisson process. So what we do for that is, firstly, we're given the first condition, that is that for the probability that in the first 2 minutes at least one customer arrives is equal to 0.3. So the opposite of that will be that no customer arrives. So since we're taking the opposite, so we'll do 1 minus 0.3, that's 0.7. So now we know the probability 0.7. So we'll put the variables in the equation above and we'll solve. So we get 0.7 is equal to e to the power minus 2 lambda. 2 is because we have from 0 to 2, right? So t is equal to 2 and k is equal to 0. So we do 0. Anything to the power 0 is 1 and 0 factorial is 1. So both of them are 1 by 1, that's 1. Then we get this equation. Now in order to solve this equation for lambda, we take a log on both the sides. By doing so, we'll eliminate the exponential factor. So we take a log of 0.7, which will be equal to the log of e to the power minus 2 pi, which will minus 2 lambda, which will be the same as minus 2 lambda. So this turns out to be minus of 0.154, which is equal to minus 2 lambda. On solving, we get that lambda is equal to 0.077. That's the first answer, first part. The second part says that we have to find the probability that within the first 10 minutes, at least 2 customers will arrive. So now the probability of getting 2 customers in the first 10 minutes is the same as 1 minus the probability of getting either 1 customer or 0. Right, so because it says 2 or more. So this will be the one. So what we do is, now we have the values of lambda, we have the value of t, 0 to 10, so t is 10. Also we have the value of k, for this is 1 and in this case it's 0. So we substitute the values in for both the cases and we solve it a bit further. So we come out with this expression, that's the final one. So probability that within the first 10 minutes at least 2 customers will come there is 0.180. That was the second answer. The third part says that we have to find the probability that in 1 minute exactly 1 customer will arrive. So now for that, we have our time set from 0 to 1, the number of customers k, that's equal to 1. We again punch in the numbers into the equation and we get the following one. We can solve this again same way as earlier, we just put in the values. We get the answer as 0.07129, so approximately 0.0713. That's the third answer. Then the fourth part says that we have to find the probability that in the first 3 minutes no customer comes. So that means within the time span of 0 to 3 minutes, the number of customers, that's k, is equal to 0. So for that, we punch in the numbers again. E to the power minus lambda, that's 0.077 into t3 into lambda t, same thing, to the power k, that's 0 because 0 customers, divided by k factorial. 0 factorial, again 1, 8 to the power 0 goes to 1. So we have e to the power minus 0.077 into 3, that's 0.793 into 1 for this expression. So our final answer is 0.793, which is the probability that no customer will come in the first 3 minutes. Thank you.